Now, coming to the characteristics of this P channel JFET, there are two characteristics we have already seen for N channel JFET, drain characteristics, and the second one is transfer characteristics. First we will go for drain characteristics. Drain and transfer characteristics we are going to explain for P channel FET also. Drain characteristics is VDS versus ID at constant VGS. So this is the characteristics. In the working we have clearly seen what happens when you apply only VDS, no VGS. When you apply only VDS, ID was flowing here. So you go on increasing VDS, ID goes on increasing, but at one particular VDS, which we call it as pinch of voltage, ID becomes constant. This part you can see. This part you can see here. ID is becoming constant. This happened when VGS is 0. Now you apply some amount of VGS for which ID decreases. You can see when VGS was 0, this was the maximum ID level, which we call it as IDSS. Now it is decreased to this level because VGS you have applied. Same thing initially when you apply VDS, ID goes on increasing at one particular value of VDE, yes, that is VP, ID becomes constant. If you further increase VGS, it again ID again decreases. If you further increase VGS, ID may become 0 here, which is shown as a cutoff part. So this graph can be split into three parts: cutoff, ohmic region, saturation region. Coming to the ohmic region, Ohm's law, that is V is equal to I into R. As you voltage, that is which tells that voltage is directly proportional to current here. So see here, voltage at this part, you can see this part. You have applied voltage, current went on increasing. Current goes on increasing, current goes on increasing for the increasing the voltage. Therefore, it is ohmic region. Cutoff, here the current is 0, almost 0, negligible value for increase in VDS. That is cutoff region, no current. Saturation, though you applied VDS, no change in the current. Current is becoming constant. Saturation level it is reaching for any increase in the voltage. This is explained as a saturation region. So this is drain characteristics. If we understand the working of P channel JFET very clearly in a very refined way, we can explain the characteristics of P channel JFET. Next, coming to transfer characteristics. What is this transfer characteristics? Now here it is VGS versus ID at constant VDS, same as the N channel JFET, wherein it was clearly explained. See, from this graph you can understand here. See, VGS is 0 at this point. When VGS is not applied, ID is going to have a maximum value. As you go on applying VGS, this ID keeps on decreasing, and it may become 0 for the maximum value of VGS. So this first curve you can see for a particular value of VDS. Second curve you can get for another constant value of VDS here. Same thing, VGS 0 volts, ID maximum. You make VGS maximum, ID keeps on decreasing and it becomes 0. This is transfer characteristics of P channel JFET. Hope you have understood. Transfer characteristics is VGS versus ID, whereas drain characteristics is VDS versus ID, which can be split into three parts: cutoff region, saturation region, ohmic region. Here you are going to explain VDS versus ID. You are going to explain VDS versus ID. In the transfer characteristics, you are going to apply VGS versus ID. So, voltage against current, voltage against current. Here you should explain, as you go on increasing VDS, ID goes on increasing, but at one particular value of VDS, ID becomes constant till you apply VGS. Once you start applying VGS, ID keeps on decreasing and it may become 0. The same thing you are explaining here. taking only ID versus VGS. This is all about the characteristics, drain and transfer characteristics of P channel JFET. Thank you.